Hi all, Mrs. Arndt here. This is your Math 3, Week 3, Lesson 2 on exact values of trig functions. So one of the things that I definitely want to say is we want to use the unit circle here. I don't expect you to have these memorized, and so if you have not checked out the unit circle video just yet, now is a great time to make sure you have that or to make sure you have your notes. So here's what my unit circle values looks like. I have my angles in degrees, but I specifically have the angles in radians. And so I know this is 30 degrees, 45 degrees, 60 degrees, 90 degrees, but I also know that it's pi over 6 and so on, because we're going to see exact value problems in radians and in degrees. And as long as we have these values, we're good to go. So here on example 1, it's asking us to write down the cosine ratio of 180 degrees, but we're using the unit circle. So when we knew that cosine of any angle is always equal to x over r, the unit circle has a radius of 1. So if r is actually 1, x over 1 is just x. So when we are writing out these exact values from our unit circle, anytime it asks us for cosine, we just need to write down the x value at that spot. The same is true for the sine ratio. Sine is y over r, but if r is 1, well then sine of theta is just y. So when we're asked for sine, we just need to write down the y value at that spot. The last one is the fun one. Tangent of theta is y over x, the opposite over the adjacent side on a right triangle. Well, y and x are going to be from our coordinate pair, so we're just going to have to use that and reduce that potentially. So let's take a look. Example 1 asks us for cosine of 180 degrees. So 180 degrees is right over here, and cosine is x. So our x coordinate on the unit circle is -1. That equals -1. So that's our exact value. Here in example 2, we're looking at sine of 210 degrees. So 210 degrees is 30 degrees past 180. So here's where we are, 7 pi over 6 or 210 degrees. And that's our x and y coordinate pair. So we're looking for sine there. So we need the y value. So the y value is -1/2. So that's our answer. Sine of 210 degrees is -1/2. So far, these have not been too crazy. Like, there aren't any weird numbers or square roots or anything, although we know they do exist on the unit circle. So, I mean, you could take cosine of 180 and see that it's -1, or sine of 210 and see that it's -1/2. Okay, so that's true. What else is out there? Tangent of pi over 4, for example. Okay, so here we have a radian. So we've got pi over 4, and then they're asking us for the tangent. Well, tangent is y over x. So we have to think about putting our y coordinate divided by our x coordinate. So let's kind of see what that might look like. Square root of 2 over 2 divided by the square root of 2 over 2. Well, you might recognize this. Anything divided by itself is always equal to 1. So that's one way of thinking of it. The other is that we never divide fractions. We always multiply by the reciprocal. So it would really be the square root of 2 over 2 times 2 over the square root of 2. And anything divided by itself comes out to 1. Okay. So that's our final answer, our exact value for that tangent. What about something else? Tangent of 5 pi over 3. 5 pi over 3. So if we look at where we are, here's 5 pi over 3. It's 1 2/3 pi. And so it's tangent again. So it's asking us to take the y value divided by the x value. So this is another place where it might be helpful to think about multiplying by the reciprocal. So we have our y divided by 1/2 or times 2 over 1. So the 2 over 2 cancels, and this is equal to the negative square root of 3. So that would be the exact tangent value at 5 pi over 3. So use your unit circle, head on over to Delta Math, and try out those practice problems.